Hi, everybody. I wanted to get started today showing you a new Kaggle dataset. I thought this was really interesting. It's allowing us to analyze the COVID-19 virus and understand some of the causes or really the factors that make this virus unique. Really understanding some of the techniques that you can use to analyze, for example, some of the unsupervised or deep learning techniques, maybe some NLP. To really get into some of the features and better understand all of the things that may be contributing to some of the panic and scare that we see going on, at least within the United States. Now, I know this is a much more broad global issue, but being that I'm based in the United States, I'm centering my discussion there. So it's interesting having come back from my world tour of the Open Hacks that, I traveled to Milan in December. I was in Zurich as well in December. I went to Istanbul in January, so Turkey, and then went down to Australia most recently, about 2.5 weeks ago. And coming back from Istanbul, outside of the foot issue that I had, I was very sick. I lost my voice then when I was in Australia, but I've now recovered. So because there's some issues with testing kits and having them available, I don't think I have anything. But I am better now. I don't have fevers. I don't have cough. I don't have any of the symptoms, but I have um, kept myself at home. I have literally not left my home. And so I think this self quarantine has really helped. My son is also at home. So my partner's at home. And, we've been just, both washing our hands slightly obsessively, keeping things Lysoled in terms of door handles, not touching our face with our, mouth, eyes, those things that can help contribute or spread the virus. And then, of course, I wanted to actually use data to analyze and find out some of the real factors. Here we are. So you can see on my screen, I am accessing this particular notebook, very much like a Jupyter notebook, using Kaggle and the Kaggle kernel. So in this instance, it's a Python 3 kernel. You'll understand more as we get into this that I first go into some of the background around COVID-19, exactly what is this virus, how is it different than other viruses, and then really deep dive into the existing data set that Kaggle provided, as well as a newly cleansed version that we will both analyze and use Power BI to visualize. And so come along with me and we will take a look at all of this. And so you can see here as I go through my notebook, I just do a really quick background check from the data that's provided to better understand, what exactly is this virus that we are analyzing without any sort of healthcare domain knowledge. Although my dad, being an infectious disease specialist prior to his retirement, I have maybe a more keen understanding of this domain area. But again, I am not a medical practitioner. I am a data scientist. And so let's just say that we are all at a level playing field when we are looking at, exactly what is coronavirus. And so, just getting started there and looking at, what is coronavirus. Some of the, quick keys. I'm using a MacBook here. It is the new MacBook 2019, 16-inch MacBook Pro. And I am doing shift return, much like you would in a Jupyter notebook, to go ahead and execute or run the command blocks. And so anything you see with text is a metadata command block, meaning it is just text or it is descriptors, visuals, typically not code blocks. But again, you would use the same shift return to execute those code cells, or go ahead and run all, depending on where you are with your commit of this notebook or your development as you move along. So this is a family of viruses that I thought was really interesting, that can cause anything from the common cold and all the way up to, in the past, I'm sure you've heard of things like SARS and MERS. Those were the very hot topics in terms of virus scares, say a few years ago. And so coronavirus is a family of viruses that can cause a range of illnesses. So from the common cold all the way up to SARS, MERS, and other very much more life-threatening viruses. It is named after its shape, and I'm sure a lot of you have seen either via the news or watching YouTube videos or online the shape, which takes the form of a crown, and it has little protrusions around it. So it looks like a little friend with a crown on it. And this is what has sort of factored it as coronavirus. You can see I have a link in here really explaining what it is in a much more medical and in-depth terminology. And so real quickly, just how did this outbreak occur? And this recent outbreak of coronavirus is at least, and I don't by any means prescribe to this. I think that we don't exactly know yet, but it is largely held or a popular belief that this coronavirus is believed to have occurred in a market for illegal wildlife in the central Chinese city of Wuhan. And health authorities in China and the WHO, or the World Health Organization, are currently investigating this. And I think it's really important to make sure that, we don't spread false information or fake news, and we follow it on a day-by-day basis because things are changing rapidly. And so again, I include some links of some information that others have shared. I don't necessarily, agree with some of the descriptors or some of the information shared. I think that, in terms of, what you should listen and believe to, I think you should subscribe to whatever form of news you believe in. And hopefully, things like the WHO, things like the CDC, those are news sources that you should follow and have alerts against, instead of, Twitter or your family or things that you've heard or picked up, from your colleagues, because that's really how a lot of this misinformation gets spread. And so, again, there's a lot of different informative videos on YouTube. One of the great things about IPython notebooks or Jupyter notebooks is the ability to embed videos and to have additional information. And so what you see here is embedding exactly that. In this instance, you can see a YouTube video embedded here.
2019, when health officials in China
and so in this instance, you've got an almost fear-causing video here of what is coronavirus.
China. A rapidly growing number of people were developing a dry cough and fever before getting pneumonia.
Now, again, I don't want to spread misinformation, but I think a very helpful video is put together here by Kaggle. Kaggle is one of the most informative, interesting platforms. So we'll go ahead and watch this.
This virus is the severe acute respiratory syndrome related coronavirus 2 that causes the disease called COVID-19 and that everyone simply calls coronavirus. What actually happens when it infects a human, and what
I love the visuals of this, by the way. First of all, I think you should donate if you can to Kaggle. They put a lot of effort into these free videos on YouTube. Your kids will love them if they haven't found them. And they're very informative.
Material and a few proteins, arguably not even a living thing. It can only make more of itself by entering a living cell.
Much like in a virus.
Corona may spread via surfaces, but it's still uncertain how long it can survive on them. Its main
Again,
way of
don't
seems to be
spread misinformation.
Cough, or if you touch someone who's ill and then your face, say rubbing your eyes
like
or
I
nose.
said, don't touch your mouth, eyes, if you can avoid it.
Cases arrive as a stowaway deeper into the body.
Oh, that bad stowaway.
Its destinations are the intestines, the spleen, or the lungs, where it can have
and again,
the
this is
dramatic
based on the
effect.
most recent information
Even just a few
available as of
coronaviruses
2020.
can cause quite a dramatic situation. The lungs are lined with billions of epithelial cells.
Look at all those
These are the
epithelials.
border cells of your body, lining your organs and mucosa, waiting to be infected. Corona connects to a specific receptor on its victim's membrane.
And you see the
to
ACE2
inject its
receptor
genetic material.
accepts it.
The cell, ignorant of what's happening, executes the new instructions, which are pretty simple: copy and reassemble.
And
It
this is
fills up
how
with more
it
and more
infects
copies
and
of the
spreads
original
so
virus
quickly.
until it reaches a critical point and receives one final order: self-destruct. The cell sort of melts away, releasing new corona particles, ready to attack more cells. The number of infected cells
And you can
grows
see here how rapidly
exponentially.
it grows.
After about
Again,
10
it's an
days,
exponential
millions
growth.
of body
And after
cells are
about 10
infected,
days,
and
you've got millions and
viruses
billions
swarm the
of
lungs.
these swarming
The
viruses
virus has
within your
not caused
lungs.
too much damage
I
yet,
don't want that
but
in my
corona
lungs.
is now going to release a real beast on you your own immune system.
Ooh, now it's the
The immune
beast.
system, while there to protect you, can actually
I've
get
got an
pretty
itch on my
dangerous to
nose.
yourself and needs tight regulation. And
I
as
want to
immune
scratch
cells
it.
pour into the lungs to fight the virus, corona infects some of them and creates
And
confusion.
you see how it creates this
Cells
confusion
have
within
neither
your
ears
immune
nor eyes.
system.
They communicate mostly via tiny information proteins called cytokines. Nearly every important immune reaction is controlled by them. Corona
Hence why
causes
this is
infected
such a
immune
big
cells
deal.
to overreact and yell bloody murder. In a
Bloody
sense,
murder!
it puts
I'm
the
feeling
immune
angry,
system
oh
into a fighting
Todd!
frenzy and sends way more soldiers than it should, wasting its
Soldier,
resources
soldier,
and
soldier.
causing damage. Two kinds of cells in particular wreak havoc. First, neutrophils, which are great at killing stuff, including ourselves.
Ugh,
As they arrive
no
in their
good.
thousands, they start pumping out enzymes that destroy as many friends as enemies.
That sounds
The other
like some of the
important type
friends
of
I used
cells
to
that
know
go
in
into a frenzy
college.
are killer T cells,
Just
which
kidding.
usually order infected cells to commit controlled suicide. Confused as
Controlled
they
suicide
start
sounds
ordering
terrible.
healthy cells to kill themselves too.
No,
The more
poor
and more
healthy
immune
cells. I
arrive,
wish you could
the more
listen to
damage
some
they
other
do, and the more
information.
healthy lung tissue they kill. This might get so bad that it can cause permanent, irreversible
Oh,
damage
jeez.
that leads to lifelong disabilities. In most cases, the immune system slowly regains control. It kills the infected
Which is
cells,
beautiful.
intercepts
Those that
the
get better,
viruses trying to
it
infect
intercepts
new
the
ones,
virus,
and cleans up the
and it
battlefield.
cleans it all out,
Recovery begins.
and
The
recovery
majority
occurs.
of people infected by corona will get through it with relatively
Fever
mild
and a dry
symptoms.
cough.
But many cases become severe or
Especially
even critical.
those that are
We
elderly.
don't know the percentage because not all cases have been identified. but
Exactly.
it's safe
This
to
is
say
where
that
we
there is
talk
a lot
about the
more
fake
than with the
news
flu.
and the numbers that have been
In more
reported.
severe cases, millions of epithelial cells
We
have
just
died,
really
and
don't
with
know
them,
how many
the
people
lungs'
are
protective
affected
lining
and
is
what
gone.
that number actually
That means
is.
that the alveoli, tiny air sacs via which breathing occurs, can be infected by bacteria that aren't usually a big problem. Patients get pneumonia, respiration becomes
That's
hard or
terrible.
even fails, and patients need ventilators to survive. The immune system has fought at full capacity for weeks and made millions of antiviral weapons. And as thousands of bacteria rapidly multiply, it is overwhelmed. They enter the blood and overrun the body. If this happens, death is very likely.
And this is when death
The
occurs.
coronavirus is often compared to the flu, but actually, it's much more dangerous. While the exact death rate is hard to pin
It
down
did look
during
much
an
more
ongoing
dangerous.
pandemic, we know for sure that it's much more contagious and spreads faster than the flu.
Which is what I said coming
There
back
are
from
two
Istanbul.
futures for
I
the
want to say
pandemic like
James.
corona,
Ooh.
fast and slow. Which future we
Not
will
that I'm
see
actually proud of
depends
this
on
because
how we
now
will
I'm
react
locked
to it
in my
the early days
self-quarantine
of
at
the
home
outbreak.
like almost
A
everybody is,
fast
grounded
pandemic
from
will be
traveling at work
horrible and cost
and
many
doing
lives.
videos like this for you.
A slow pandemic will not be remembered by the history books.
But this
The worst
fast
case scenario
pandemic,
for a fast pandemic begins with a very rapid rate of infection because there are no countermeasures in place to slow it down.
right, like what we're
Why
going
is
through
this
right
so
now.
bad? In a fast pandemic, many people get sick
We
at the
start
same
at the
time.
outbreak, you have the
If the
spike,
numbers get too large, healthcare systems
and then
become
we
unable to
overwhelm our
handle it.
healthcare system.
There aren't enough resources.
We don't
like
have enough
medical staff
resources like
or equipment
beds, we
like
don't have enough
ventilators left to help
tests. I
everybody.
know we're getting
People
more
will die untreated. And
ventilators.
as more
And then
healthcare
what about our
workers get
healthcare
sick
workers?
themselves, the capacity of healthcare
Exactly. The
systems
capacity
falls
of having
even
them
further.
to treat
If
us
this
is even
becomes
worse,
the case, then horrible decisions
Beds
will have
become
to be made
taken.
about who gets to
Exactly.
live and who doesn't.
which is
The
terrible.
number of deaths rises significantly in such a scenario. To avoid this, the world, that means all of us, needs to do what it can to turn this into a slow pandemic. A pandemic is slowed down by the right responses, especially in the early phase, so that everyone who gets sick can get treatment and there's no crunch point with overwhelmed hospitals.
Exactly. Hopefully this is
Since
what
we
we're
don't
doing
have
right
a
now.
vaccine for corona, we have to socially engineer our behavior to act like a social vaccine. This simply means two things: not getting infected
And not infecting
not
others.
infecting others. Although it sounds trivial, the very best thing you can do is to wash your hands. Soap is actually
Oh, they're
a
so
powerful
dry.
tool. The coronavirus is encased in what is basically a layer of fat. Soap breaks that fat apart
Oh,
and
you
leaves
little
it
fat
unable to
lipid.
infect
We're
you.
going to wash you
It
away.
also makes your hands slippery, and with the mechanical
Well, my
motions
hands
of
do
washing,
not feel slippery.
viruses are
They
ripped away.
feel really, really
To do
dry.
it properly, wash your hands as if you've just cut up some jalapenos.
Oh, I was
or
just about
put
to
in your
say, like,
contacts
is that like
next.
washing your hands with
The
a
next thing
jalapeno? But
is
I get it.
social distancing, which is not a
Metaphor.
nice experience,
I think
but a
I
nice
actually
thing
have
to
put
do.
in my contacts
This
after
means
cutting
no
up peppers
hugging,
before.
no handshakes. If you can stay at home, stay at home to protect
Yes,
those who
I
need
have
to
been
be
at
out
home
for
now for
society
weeks.
to function. from doctors to cashiers or police officers. You depend on all of them. They all depend on you.
And yes, toilet paper is still having a
On
run.
a larger level, there are quarantines, which can mean different things, from travel restrictions or actual orders to stay at home. Quarantines are not great to experience and certainly not popular.
Super
But
boring.
they buy us and especially the researchers working
Hopefully
on
it buys
medication
them
and
a lot of
vaccination
time
crucial time.
and
So
slows
if you are
down
put under
the
quarantine,
response.
you should understand why and respect it. None of this is fun. But looking at
Individual
the big picture,
fund meter
it is a really small price to
but
pay.
it is a small price
The
to pay.
question of how
Hopefully our
pandemics
outbreak
end
will become
depends
much
on
more
how
like the
they
green
start.
line there.
If they start
This is where having the
fast with a
data is
steep
going to
slope,
become
they
much
end
more
badly.
interesting to
If
analyze.
they start slow with a not so steep slope, they end okayish.
Yes.
And in this day and age, it really is in all of our hands. Literally. And figuratively.
So dry hands is just
huge
a small.
thanks to the experts who helped us on
And
short notice
here
with
are
this video,
the amazing
especially
people who
Our
make these
World in Data,
videos
the
and
online
Our World in
publication
Data.
for research
That's
and
where
data on
I'm
the
getting a
world's
lot of my
largest
data
problems
as
and how
well
to
for
make
this
progress
Kaggle
solving them.
competition.
Check out their site. It also includes a
It's got a
constantly
lot of great
updated
symptoms
page
and
on
a
the
lot
corona
of
pandemic.
other information and why does it last. And again, check out Kyrgyzstan on your own. It's a great website. All right, so going back into our
Imagine you were alive back in the 1980s and were told that computers would soon take over
all
everything.
right, so
From
now
shopping
let
to
me go
dating
ahead and
and the
stop
stock
that.
market. That billions of people would be connected via a kind of web.
All right,
That you would own a
just bear
handheld
with me
device,
1
orders of
second.
magnitude
Now
more
we're
powerful
learning
than
much more
supercomputers.
about CRISPR,
It would seem absurd.
and wow, this may be
But then
interesting
all
for
of it
you. We're going to go ahead and end that note and go back over to our Kaggle. Yes, and so what I am going to just do quickly is make a change here in my video that we were just watching. All right, so I think there we go. And so what you can do in these Jupyter notebooks or Kaggle notebooks is just replace in the name of the YouTube video. And hopefully I captured the right one. Okay, maybe not. Oh, then again, it's still running. So we'll see what this comes back with. And in the meantime, what's interesting as we look at, all right, so let me just go ahead and reopen. What we were looking at on Kyrgyzstan in its entirety. All right, so we want to grab here the coronavirus and we want to understand what is the actual code block. And it looks like here we've got
in December 2019,
we've got some copies of it, which is interesting. If we were to go over and open this on YouTube as opposed to
notified the
this
world that a
partner
virus
site,
was spreading through their communities. In the following months, it spread to other countries, with cases doubling within days.
We'll go ahead and stop this.
This virus is the severe acute respiratory syndrome related coronavirus 2.
All right, and we're back to our notebook here and take a look. Okay, I had a feeling this is not right. There we go. Now let's see. And we'll wait to see what we get here. All right, so one of the great things about being able to copy these videos and download them and share them and save them is that it makes it so much easier to watch later and to share with others, especially those that are relevant and meaningful. And I think anything with Kyrgyzstan you'll find is exactly that. So
the causes that
we're going to go ahead and come back to our let's see. We're going to pause this. Okay, so we're resuming recording now. I don't know why the exact same code that I had in here 2 seconds ago didn't work, but now it does. So essentially, what you can see here is I've gone ahead and appended in a piece of metadata. So now I can embed in my Kyrgyzstan video that we were just watching. And so the way you get that metadata is I use a sharing debugger, or you can just use the URL. This is something provided by Facebook. So if you want to see, for example, the coronavirus link, you can go ahead and copy the video URL and go ahead and paste this in the sharing debugger. And you'll see here, this little code here is the code that you're going to want to append into your notebook. That's a Jupyter notebook, IPython, in this instance, the Kaggle notebook. It all works the same. So you're going to use the same ipython.display command block, and you're going to use the YouTube embedded video. And now you can see how I changed it from what was there previously to now my coronavirus version. And I'm going to go ahead as we move along, and I'm just going to make a copy and download my version of the notebook. And you can see here some other videos, but I'm going to go ahead and I'm not going to keep those. So you see this little delete icon. I can just go ahead and delete this. All right, and I'm going to actually add some metadata. All right. And I want to make sure that I spell Kyrgyzstan right. I would hate to spell their name wrong, because they are just so good at what they do. Let's go ahead and copy this link address, and we'll come back here, and we'll go ahead and put that into our, there we go. And we're going to put their channel in there. So Kyrgyzstan. I always end up spelling this wrong. There we go. Kyrgyzstan. And clearly saying it wrong. And you'll see here I'm just typing in plain text. And then when I hit Shift Return, I go ahead and I get a proper command block here. And I can do some things like, let's just say I wanted to say href, just using normal syntax, and then this, and then go ahead and cut this over, and we'll paste that in there. And then we're going to go ahead and just put the normal name of Kyrgyzstan in there. And we'll go ahead and end with a and then we're going to back that. We're going to put Kyrgyzstan, and we're going to end it like that. And now you can see, because just using normal HTML, I now have a link in there over my Kyrgyzstan, pointing them back to give them credit for their amazing video, which you can see here. Okay, now there are a whole bunch of Kaggle information and other people who have done some analysis that we can use in terms of our data set. And so you can see we've got a whole bunch of articles and a list of resources in this Kaggle particular. Let's just go ahead on Kaggle. And to help us complete the tasks with this data set. And so just another interactive day-by-day analysis and giving credit where credit is due, using all of these different links. All right, so now it's going to come time to cleaning our data set. So basically, again, we want to just analyze, what data we have to help us wrap our head around this information. All right, so now we're going to just name some callouts and go ahead and understand and clean our data sets here. So I'm going to go ahead and use Pandas, which is a library that you saw me reference earlier in my notebook, as you do with any Jupyter notebook. So you can see I have NumPy here, which will help me with some of my math functions. I have Pandas, which will help me with data processing, with CSV file, doing all that read, and then Seaborn, of course, is one of my favorites for visualization, other than things like Plotly or Power BI in this instance, which we're going to use much later on. And so in this instance, I'm going to go ahead and name my Flora file, meta data, and all right. So now we want to go ahead and find all the places where we might need to make a change. And there's 19 of them. And let's go ahead and go down. Oops. And next. And next. And we're going to keep on doing that through these 18. Which will start speeding up here. So I'm going to go ahead and copy it. And then just paste it in front. And, ooh, nice. This one has 3. Speeding us up. All right. Takes us to 10. And 11. And then okay, we have roughly 6 more. And we just want to make some call outs here. Oh, we have 3 in here. Lovely. There we go. This takes us 14 and 15. Ooh, nice 16. And then we have 2 more. We're going to say Laura, and then this. And then, of course, for our new files and our cleansed file. And let's see if we've captured them all. All right, and now we can go ahead and run these. So now all we're doing is we are referencing in our data set. So here we are using Pandas to read in the data set provided to us by the Kaggle challenge. And you can see here, it is this CSV file, all sources metadata. And then we'll just keep going through and hitting our Shift Enter. Easy peasy. And here is just looking at the head of our file. And so that just means the top rows. So in this instance, we're looking at the top 4 rows to get an idea of what data is included in it. You can see here that we have our source of where the information came from, the title about the enzyme, the period, the epidemiological information, public health response, and so forth. We can see some other information like IDs, some abstracts, some information, some dates, some other license if there's a Microsoft Fellow or a WHO, so a World Health Organization reference, all of that information, and of course the authors and the date, most of which have been published in 2020. So it's just a really quick snapshot of your table. And so each value, is got some meaning. And so I thought this was a really great summary put together by another Kaggler. And a lot of this can be understood from the README of the data set that's been provided. So I would highly recommend that you do read that README. And so just trying to clean this up to better help you understand. so that when you go back and you look at this, you know what you're looking at. All right, so just clean that up a bit. And come down here now, and we're going to look at some information about our data set. So again, this is really taking the pandas data frame and taking a look at the shape of the data. So we can see here that we have 14 columns, that we have a total of 29,500 entries from 0 to 29,499 rows. We can see all of the non-null objects. We can see the data type, object and float primarily, for each of the columns. And we can see how much memory usage. We can see basically we have 2 floats and 12 object types summarized here. So really helpful little command is using this info to really understand the metadata about your data or the shape of your data. You can also see if you have any nulls or significant nulls in your data set. And so again, before you really dive into your data frame and really want to get into it, just very helpful. Again, if you want to then take it to another level, describing your data set. So in this instance, using a describe and basically including all will give you things like a unique count, an all count, the frequency of how frequently you're going to see certain terms, the titles, you know, basically your different column headers. So in this instance, we've got 4 unique of these SHA IDs. We've got 67 different titles. And you can see as we go through the DOI, we've got 35 of them that are unique and so forth. We've got a lot of NANs, so eventually we might want to clean those up. And of course, any of these numeric ones, because these are text, are going to report up as NAN for now. So there's just some things that we can see in here. We can see that we have some duplicates that we would want to clean out. We see that we have some DOIs that are missing. And we see that we have roughly 1732 unique journals in terms of the scholarly articles. So in terms of cleaning our data set, we're going to go ahead and drop the duplicate and pre-process that DOI column so that we can have a fully fledged DOI. So in this instance, to do that, we're going to go ahead and use the drop duplicates command. We're going to say we're going to do that on a subset of the title. So anything that's duplicated, please drop, and we're going to do that in place. And then let's look at the info again. And so this time, if we were to compare it, we can see here that we have out of our 24655 entries, we now have 29,138 from 0. And so if we look down, we can see that now, if we go over to our title, which is here, we have 24654. So now we have taken our titles and we have